Hey guys, what's going on? It's Shadowstorm here with a new podcast and gameplay video combo. I figured I'd play some Wizard 101 while I did this brand new podcast. That way I give you guys something to watch while you listen in. Today we will be discussing various space-related subjects with my guest and co-host, Havoc. How are you doing today?
Hello. I'm good. How are you?
I'm doing really good. For those of you who don't know, we've had quite the issues. This is our take 2. Thank you for coming. Again.
Thank you for having me again.
As there's no time like the present. Are you ready?
Yep.
Alright, let's get started. Our first subject today is space travel. Can it be improved? How? What are we doing wrong about it? How could we make it more efficient?
Alright, so right now, the best and closest we have to interstellar space travel is SpaceX's Falcon Heavy mega rocket. SpaceX plans to launch the first commercial mission as early as next month, according to CNBC. SpaceX has officially announced a launch target for the Falcon Heavy mission. The Falcon Heavy rocket is the most powerful reusable rocket to date, which is pretty impressive considering everything that we've had before. It's definitely a step in the right direction of getting out there and going further and higher than ever before. What can be improved for space travel? There's a lot that can be improved because we don't have everything figured out just yet, but we're getting there. Some of the things that can be improved is pretty much everything: shielding, fuel, the size of the rockets, as well as the weight of the rockets, because space is a very dangerous and hostile place. As of now, we only have a minimal shielding in place for space rocks and debris, as well as solar radiation. We only have the bare minimum that we know how to make, but we can go further. And by that, I mean in terms of shielding from space debris, space rocks, and radiation, we can start looking into magnetic shields for our spacecraft, as well as, a higher form plasma shields. But magnetic shields would be better on both ends because we can use that to protect us from radiation, because that's what the Earth uses to protect us from radiation, is magnetic field. But we can also double it as a protection from space debris, as most space debris from other ships, other launches that we've done in the past that are littering around the planet, as well as space rocks, they're all magnetized by the solar radiation, by the solar flares and all the radiation that's out there. They're magnetized, so you can use the magnetic fields to kind of like push the other debris out of the way, or just redirect it past us.
Why not create a device that can just go and clean up the... Okay, well, I guess it's nearly impossible to clean up all of the trash, but at least figure out where it is and clean it up.
Well, there have been talk and debates about this, about what can be improved to clean up the debris around the atmosphere, or around the planet, that from other launches. There's only been design concepts, and some effort has been taken into account to actually send some type of like probe or something like that to go clean it up and get it out of get it out of orbit, essentially. But even if we did do that, that only deals with part of the problem, as there's still space rocks and meteors and everything else that's still way past our planet and is still a very huge threat to us.
Interesting.
The fuel, we need a more sustainable fuel source that's long-lasting. The fuel we use now is refined kerosene and liquid oxygen. This creates a lot of carbon dioxide when burnt. However, the shuttles we use now require huge quantities of fuel, which in turn add weight, which makes it harder to lift out of orbit. My take on this to improve this would be using electrogravity. Yes, you do need a lot of power, and the theory is still iffy, but it's a theory nonetheless, and it's being tested, and I plan on testing it one day. One day soon, hopefully. So electrogravity could be a way to go down if we did the research for it. The using electrogravity would also match with the magnetic shields because you'd have that immense power to begin with anyway to get us out of orbit, to get us the power to get to places, but it would also add the power needed to create the magnetic shields. So those two kind of like go hand in hand and work well with each other, in my opinion anyway. Using electrogravity, it would propel a spacecraft out of our orbit and out of any other orbits fast, quickly, efficiently, and it'd be way better and safer than fusion energy or other fuel sources that are going to run out, or we have to worry about them running out and depleting and everything like that. So it's definitely a lot better because we know the basic fundamentals of creating electricity, but if our resources for fuel run out, we're screwed. And that's that.
That brings us to wormholes. What are some ways that we could create wormholes? What are wormholes? Can they be used for time travel? And what are the possible dangers or cons of creating them?
Wormholes are a theoretical concept created in 1916, which illustrates that a white hole, the opposite of a black hole, connects to a black hole, creating a tunnel through space and time. This was conceptualized by Ludwig Flamm while he was reviewing Einstein's theory of general relativity. In 1935, Einstein and Nathan Rosen used the theory of general relativity to elaborate the idea and proposition of bridges through space-time. Theoretically, this would create a shortcut to reduce travel time and distance between 2 points. The term became known as the Einstein-Rosen bridges, or wormholes. Mathematically, wormholes are proven to exist, but none have been found to date as of yet. But I'll elaborate on that in a second. Certain solutions to the theory of general relativity allow for the existence of wormholes where the mouth of each is a black hole. However, a naturally occurring black hole formed by a collapse of a dying star does not itself create a wormhole. Primordial wormholes are predicted to exist on a microscopic scale. Wormholes are also predicted to be very unstable. So think quantum-sized wormholes. It's kind of like... It's very super microscopic wormholes that can connect points of space and time, and we have to figure out how to open them and get them bigger because you can't find any bigger wormholes out in space because you would need some very exotic type of matter in order to stabilize a wormhole, according to Sue, HSU. I don't know his last name. That was all that was there. Exotic matter from different. Exotic matter is different from dark and antimatter, so that rules that out. We can't get those for this. And negative energy essentially is what we need to create the density and the large amount of it to open a wormhole, stabilize its behavior, and the only problem is that the matter is only observed in certain vacuum states as part of a quantum field theory. So we can rule that out as a source of fuel or a source of power to open a wormhole. Wormholes, hypothetically, could not only connect points in time and space, but could also connect two different universes. and I'll elaborate on that down the road as we go. Regular matter, hypothetically, could and would destabilize a wormhole. But if going on to potential ways to create a wormhole, aside from using nearly non-existent exotic matter, in Einstein's theory of general relativity, in the presence of mass and energy, a geometrical power to allow the simulation of gravity. So, space-time could tremble like the surface of a pond and seems to be full of a mysterious form of energy that is pushing it apart. It is also conceivable for space-time to be so warped that it becomes possible to travel backwards in time. The more mass an object has, the more it warps space-time. In theory, if a huge quantity of simulated mass or energy were to be directed towards a singular point, it could potentially open a subatomic wormhole for a fraction of a time. Of course, this doesn't come without danger of emitting too much simulated mass, as too much mass, especially in a singular point, could hypothetically, or not hypothetically, could create a black hole. On a small scale, even then, creating a black hole on Earth could be consequential and devastating, as black holes are fueled by mass and objects. So if you create a black hole on Earth, we're kind of screwed. It's just going to keep growing. No matter how, if you open a wormhole big enough for something to go through, but use too much simulated mass to open it, you could create a condensed black hole which could suck in all the matter and mass in the general area and expand and get bigger until the entire Earth is engulfed. But the good news is we can use this hypothetical exotic matter that's used to open a wormhole. Hypothetically, we can use the same type of exotic matter to close a black hole, as black holes feed on mass and regular matter and energy. To get bigger, if we used a negative energy from this exotic matter, we could close a black hole.
I'm assuming just like a black hole sucks in light and it can't escape, a white hole releases light. What is a white hole? Oh God, no, not that. I'm assuming that's all you've got for that category. Oh. More technical difficulties, people. Do not fear. Obviously, we're having internet issues with our host and myself. Bear with us. And we're back. Let's try that again.
Hello.
And we're back, I guess. Huh.
Sorry.
Yeah. Don't worry, people. Internet connection issues. It sucks, but it happens. My internet kind of lagged out a bit too. Don't know why.
Did you catch the ending of what I had talked about?
Yes, I did.
Okay.
Luckily.
Yeah. It happened as soon as I said that. I was like, oh, okay, whew, that was close.
Yeah, that was really close. But thankfully it doesn't stop recording because it logged out of my game. It just will be recording a black screen until my game gets back up. And was that the end of your wormholes I believe we were on?
Yep, that's the end of it.
That brings us to interstellar colonization. How should we start? With space stations or bases on planetary surfaces? How should we do it efficiently? Why have we not found Earth 2? Pros and cons of colonizing space. Feel free to start whenever you want.
Okay, so how to colonize space effectively and efficiently. It is possible to start doing it by sending modules up to connect to make a bigger space station, but also to create kind of like a civilization out in space. The problem with that is that you only have a limited amount of resources. You can go to Earth. As of now, this would be the best effective way because Earth is still fine. Earth still has resources we can use. So when we send up these modules to connect to each other to create a bigger space station for colonizing the orbit of Earth, we can send people up, we could send resources, we could send everything we need to, and still keep in touch with Earth and send other resources if need be. That's the good side to it. The downside comes when Earth runs out of resources and Earth either gets destroyed or is devastated in some way, then we no longer have those resources and we're kind of trapped because we only have a limited amount of oxygen by then. Or if we create a system that allows oxygen to be created up there, like some type of farm or plant system up there, we could do that to sustain ourselves, so that's not an issue. The issue comes when we want to go somewhere else to colonize other places. We only have a limited amount of materials to do that, and if we run out, then we're kind of stuck. So we have to take precaution and use those resources to the best of our ability and best as we can, so that way we don't destroy them or use them up too fast. But as of colonizing other planets or moons, because that is a possibility too, we would need to send cargo shipments up first. The cargo needed would be some type of 3D printing device to create basic housing and facilities. We already have something like this on Earth.
Yeah.
It's like a vehicle that can 3D print houses out of recycled material. So we could use that. We need to send up fundamentals of survival, such as supply of water, food, toiletries, equipment, transportation. So that way we could have those in advance, so that way when we got sent up, everything would be there, we wouldn't need to worry about anything. To be able to travel to different star systems, a more sufficient method of travel will be required, like using wormholes, so that way we can get to and from places as fast as possible. These would include warp travel and wormholes, but warp travel isn't exactly a possibility, and I'm about to tell you why. So, Alcubierre warp drive is a highly speculative but possibly valid solution of the Einstein field equations, specifically how space and time and energy interact. This mathematical model of space-time have features that are apparently reminiscent of the fictional warp drive or hyperspace from notable science fiction franchises. In 1994, a Mexican physicist by the name of Miguel Alcubierre came and proposed the method for stretching a fabric of space-time in a way that could, in theory, allow for faster-than-light travel to happen. The idea is that space ahead of an object would contract, while the space behind it would expand. A spacecraft inside of this wave would then be able to ride to this region known as the warp bubble of flat space. Known as the Alcubierre metric, interpreted in the context of general relativity, the metric allows a warp bubble to appear in previously flat region of space-time and move away effectively at speeds that exceed light. The interior of the bubble is the initial reference frame for any object inhabiting it, since the ship is not moving within the bubble, but is being carried along as the region itself moves. Conventional relativistic effects such as time dilation would not apply, hence the rules of space-time and the laws of relativity would not be violated in the conventional sense. However, there are no known ways to create such a warp bubble in a region of space that does not already contain one. Secondly, there are no known ways to leave a warp bubble once you enter one. So, anybody who's listening to NASA, them saying we're going to create a warp drive, they're full of crap. And it's funny because I've been trying to figure out wormholes since high school, and I knew that was the best possible thing. And now I actually have the evidence to back it up and the research too. Because wormholes are mathematically possible, but also hypothetically real and theoretically real, and are seen in some instances on a microscopic scale. So they at least partially exist to the point that we could create them, whereas warp drive is just unconventional in every sense of the way. It is possible to go colonize other planets or moons at the moment. Well, it's almost possible, not quite. We're a couple years off, but it's soon enough. SpaceX plans to send its first cargo mission to Mars in 2022. They will conserve water resources and identify hazards while also putting in place initial power, mining, and life support infrastructure. A second mission will both carry cargo and crew and is planned for 2024, with primary objectives for building a propellant depot and preparing for future crew flights. All this with hopes of serving as an initial Mars base from which we can build a thriving city and a self-sustaining colony. There is a planet that researchers at the University of Hertfordshire discovered. It's an Earth-like planet. It has Earth-like climate. This planet exists in the habitable zone and is perfectly quiet old dwarf star and is part of a 6-planet system, only 42 light years away. In terms of miles, that's
a lot.
Yeah, it's a lot.
So to speak.
It's 246 billion, trillion, 246 trillion, 902 billion, 265,673,711 miles.
Jesus. I'm not even going to bother trying to put that into meters for the European measurement people.
Yeah. And that's only 42 light years away. So anything past that, we would need anything past that, or even before, sooner than 42 light years away, we would need an effective system to get there and back as soon as possible, because if we leave to go that distance to get to this planet, it's essentially a one-way trip. Because if you come back, so much time would have passed, because time is relative to the observer. So to us, not much time would have passed. We would be able to mark it on our calendars, but we ourselves, the faster we go, would not be able to understand this. Would not be able to see the time, going by fast. It would go slower for us the faster we go. But for people on Earth that are left behind, they would, millions of years could have passed, and everything would be changed. So we need an effective way, such as wormholes, to get to and from places that are long distances like this, and come back almost to the time a couple minutes after we left. So that way no time has passed at all, really.
Is that all you've got for the interstellar colonization?
Yep.
That brings us to planets and their info. I guess I could go first, with my first planet being 55 Cancri E, an exoplanet in orbit of its sun-like host star named 55 Cancri A. Its mass is that of 8.63 times our own Earth's mass. Its diameter is about twice that of Earth. It is the first classified super-Earth. Its distance is 40 light-years away. Let's see. And it's in the constellation of Cancer, given the name Cancri E. It is referred to as the Diamond Planet, as people once thought that a third of the planet is diamond and graphite, but recent studies might show that the planet might not be as precious in gemstones as we once thought. But they have not found any conclusive research on what else it could have been made of. My second planet, HD 189733b, slightly larger than Jupiter. It is 62 light-years away from Earth. On this planet, the wind speeds on it can reach as high as 5,400 miles per hour, or 7 times faster than the speed of sound. Temperatures on this planet can reach well over 900 degrees Celsius, or 1652 degrees Fahrenheit. On this planet, aside from the fast winds, it literally rains glass sideways because of the winds carrying it all over the world. The atmosphere consists largely of silicate atoms and particles. So if you were to land on this planet, you would not survive. You would be shredded to bits, so to speak.
It's like a human shredder.
Yeah.
Jeez.
Yeah. All of those glass shards and all those strong winds.
Yeah.
For my third planet, Kepler 438b is a near-Earth-sized exoplanet. It is about 640 light-years away. It is a likely rocky planet, orbiting on the edge of the habitable zone of its red dwarf star host. It lies in the constellation Lyra, or Lyra. It receives 1.4 times our solar flux. It has an Earth Similarity Index, ESI, of 0.88, the highest for a confirmed exoplanet so far. The habitable zone of the dwarf star Kepler 438 is a region where it is highly possible for liquid water to exist on the surface. It is also the most Earth-like in terms of radius and mass. Its orbital period is around 35.3 days. And that's for my third planet. And that's all 3 planets that I chose to research.
The 3 planets that I chose to research were Kepler 62f. It's only 1.4 times bigger, or 40% bigger, than Earth, and orbits a dimmer, smaller star. It's believed the planet is in the habitable zone. A modeling study suggests that the planet is engulfed in water. The planet circles its sun every 267 days. The planet is also closer to its sun than Earth is to ours, and the gravity is described as gentle.
Very gentle.
The planet is 1,200 light years away.
Wow.
Yeah,
It almost
42.
sounds like the water planet from that game, Subnautica.
Yeah,
Even though in Subnautica there were pieces of land for alien technologies and whatever, but close enough.
yeah. That also provides a sense of danger
Yes.
because,
There's no telling what could be living in those waters.
exactly, there's so many life forms that live on our oceans alone, let alone a
And
planet.
we've only discovered 5% so far of Earth's
Yeah.
water.
Yeah, so we would be severely unprepared for anything there.
One can only imagine. I mean, who knows? There could be a megalodon on that planet that's like 7,000 times the size of ours. There could be large beasts.
Yeah. I did a Kepler 186f. The size of this planet is known to be less than 10% larger than Earth. Its mass, composition, and density are not known. However, it is believed to be a rocky planet. It orbits its star once every 130 days and receives 1/3 the energy that the Earth does from our sun. It'd be a bad planet to go to because if we tried to do anything with solar energy, it would not work. We would need a lot bigger panels. We would need more panels than we do now. It's just not a good planet to try to set up on.
Just create an entire shell panels. Just cover the entire land or ground in panels.
Yeah. The planet resides in the Kepler 186 system, about 500 light years away, and is in the constellation Cygnus. The system is also home to 4 inner planets that circle a star that is half the size and mass of our sun. My last one I did was Ross 128b. It's very similar in size to Earth. It has an abundance of carbon, oxygen, magnesium, aluminum, potassium, calcium. The core of the planet is thought to be larger than Earth's. It is thought to be a rocky planet, and it is likely a temperate climate like Earth. It could have liquid water on its surface. It orbits a red dwarf star 11 light years away, so it's the closest that I've found to us.
Yes.
And
mine is a lot further away.
Yeah. And the fact that the core is bigger than Earth's could actually be a really good tool, because the bigger the core, the bigger the magnetic field. If the magnetic field is still there, we wouldn't have to worry about it as much as we do our own, because eventually cores of planets kind of like harden up, kind of,
Yeah.
and the magnetic field can go away.
I would say, how would a bigger core be better? Wouldn't it heat up the ground and stuff a lot more, since it's molten, pretty much molten lava?
It could. Well, I don't think it'd have that effect, but it would definitely have its own problems. It could cool down a lot faster on the outer edges of the core. So
True.
the magnetic field is kind of iffy on that, because I don't think we've done any studies on it to figure out what the magnetic field is like. But if I'm right, the core being bigger could be helpful in that sense, but I'm not sure.
Wow. With the talk of these planets, it brings us to our 5th category, realities, which I'm sure our friend here has had a lot of fun with. What is reality? How do we alter realities? What happens if we change a reality? Should we possibly change them?
Okay, so this is going to be a complex topic, so just bear with me. I'm going to try to explain this as best as possible.
Everyone, pause the video now, go grab your popcorn, nice soda, and begin.
So, reality is what we perceive as human beings, there are certain things in reality that we can't change that are static, like certain scientific principles, mathematics. Only our understanding of those topics change, not those actual topics. What we perceive as reality is essentially everything that is the truth of the universe. It's what we see, smell. It essentially encompasses our five senses and even goes past that to things that we can't touch or physically interact with, such as numbers. And it goes even beyond that to the fact that subatomic and quantum particles change when observed. So in a sense, technically reality is being changed every time we observe it on a subatomic scale.
Wow.
The mathematical and scientific principles that we use to observe reality and to understand reality can be manipulated to be able to get what we want to change reality. And what I mean is, imagine a food that tastes like a sandwich. Imagine a sandwich. You taste it, it tastes like a sandwich. It looks like a sandwich. And in terms of appearance and like size, and you could tell the individual pieces of the sandwich, the bread, the meat, everything like that.
Yeah.
And it smells like a sandwich, but the difference is, say it's all blue. Everything about the sandwich, the color is blue, but everything else is the same. That's changing the reality of what we believe a sandwich to be.
Oh, wow. It's a good thing you chose to say a sandwich and not a waffle. Because I'm sure you've heard of a blue waffle.
Yeah. It can go even further than that. Say we see an object. It smells like the object. It smells like something. It tastes like something. It looks like something, but it's completely different from what it all is. Those are aspects of reality: scent, sight, touch,
Or
smell.
for example, like take a car. You could change the reality. It could look like a house. It could look like a house, but it still sounds like a car. It smells like the car, the gasoline and stuff. You fix it up like a car. You drive it like a car, but it looks like a house.
Yeah, exactly. It's essentially what we perceive reality using these fundamental principles that exist in our universe. They can be altered. They can be changed. The question of should we change them? To some extent, yes, we should. Just, if not anything else, but for the fun of it.
Yeah. There's no real purpose or usefulness in it. It's just fun. It would be fun.
Yeah.
That would make sense.
Talking about reality, we can also say that actions that we take because of the things that we perceive can alter reality as well. We change reality, we actually alter reality every single day, every single second that we do things, every millisecond, every whatever. And that's because, in theory, there's a theory called the parallel worlds theory, or the multiverse theory, that every action that you take, whether it's to scratch your head, scratch an itch, pick your nose, whatever, every action, there's always hundreds of other actions that could have happened, but you chose to do that one action. So in doing that, a separate universe is created where the reality of that universe is different, where you chose to do something else, and therefore this is that person's reality, or this is that version's of you reality, and it's different from yours. And in theory, you could use a wormhole to access these other realities because there's seemingly infinite number of realities out there. And each one is different from the last because they create their own parallel universes from the actions that they take. So it continues on and on and on and on and on, and it goes on forever. And fun fact, it's actually believed that a white hole, which emits matter instead of pulling it in, it's the opposite of a black hole. And the thing is, we've never really seen a white hole.
Yeah.
But in theory, black holes in our universe open up to other universes because...
I just had a nice idea or question come into my head, but I'll ask you once you're done.
Because in the scientific principles, matter cannot be created nor destroyed, so a black hole kind of threw all of this out. It was like, where does all the mass go, and where does all the matter and energy go since it's going into the black hole? It can't just disappear, right? So the theory is that this actually opens up to another universe where the matter is emitted through a white hole, and that's where the matter goes. It doesn't get destroyed, it just goes somewhere else.
What do you think would happen if this is even possible? What would happen if a black hole and a white hole were to collide into each other?
I don't know. Because I would say a black hole colliding with another black hole would expand and get bigger, and they would kind of like feed off of each other until they just like formed into one bigger one. So a black hole colliding with a white hole, I would probably say the white hole would get canceled out because the black hole pulls in mass and matter, and the white hole emits it, so it would just constantly pull the mass and the matter out of the white hole back into the black hole, and the white hole would eventually collapse.
That's very interesting. That would bring us, unless you have more to add, that would bring us to the 6th topic. Dimensions. What are dimensions? How can we access higher dimensions, and how do they affect us?
So dimensions, to us, is not what everybody thinks. Dimensions aren't parallel universes, because parallel universes are different versions of reality from your own. So those all exist on the same three-dimensional plane that our universe exists on, that we understand and can relate to because it's our universe. We live on a three-dimensional plane. We ourselves can break down our three-dimensional world to see smaller dimensions, two-dimensional objects and one-dimensional objects. Our dimensions exist of height, width, and length. Those three things make up the entirety of our universe, essentially. We cannot, in terms of now, we can't really go higher than that because it's not physically possible to transcend into a higher dimension from our understandings now. I mean, I could be wrong in the future, it could change, but as of now, we are all exist on a three-dimensional plane that all parallel universes and all realities exist on a three-dimensional plane.
Right.
The fourth dimensional plane would be it'd be 4 dimensions of space and 1 dimension of time, instead of the usual 3 dimension of space and 1 dimension of time, which we live on. The 4-dimensional cube is actually known as a tesseract, kind of like from Tesseract. Yeah. The object has so many dimensions to it that it's harder to perceive in our physical world because we live on a 3-dimensional plane. It'd be harder to perceive the higher in dimensions you go, the higher dimensions an object is on, the harder it is to understand for us, because we weren't created on those higher dimensions.
Right.
We can only understand ours and the ones below us. So, for all we know, there could fully be four-dimensional and higher beings that transcend our understanding of things, that transcend all our knowledge, and they could interact with us because they could see below their dimensions, but we wouldn't really be able to see them. We wouldn't really be able to understand them and perceive them. And if we did, like a fourth-dimensional being, it'd be hard to understand and conceptualize, but also we would only see them for the time being that they want to interact with us in. And there could be higher. There could be fifth-dimensional beings, sixth-dimensional. I don't know how much higher the dimensions go. It's talked about and debated and theorized about how many dimensions there actually are, but nobody's actually been able to set a standard for what there actually is, because we don't know. We can't know. We can't physically know. And this just has to be one of the realities, one of the principles of truth in the universe that we have to try to understand, even though we can't see it.
That would make sense. Is that all you've got for the dimensions topic?
Yep.
That brings us to our last topic, which you have free reign over and can say whatever you want. SpaceX versus NASA. Elon Musk versus freaking, I don't know, whoever.
The government.
Yeah, the government.
Elon Musk, hands down, all the way. I've said it all throughout high school, and I'll continue saying it until something changes my mind. Elon Musk, since the early 2000s, has been the leader in space exploration, as well as advancements in the field of spaceships and in space in general. He's created the first reusable rocket. Well, not him directly, but his company has created the first reusable rocket. He's created self-guiding rockets.
Hasn't he also sent a Tesla into space?
Yeah, he sent Tesla into space.
Just because.
Just because. And he did it kind of like a test. It was an experiment of sorts.
Yeah.
But it also contained, the Tesla actually contained data bits or some type of coded information on, like, I guess some type of, like, drive or file or something like that on there.
Ooh, that's smart.
So wherever it goes, it has information about Earth.
That's really smart. Just like the, what is it, the Hubble telescope that has the golden disc?
Yeah, I think that was that.
Yeah, it's just like that, but more modern.
Yeah. The reason I love SpaceX so much is because, yeah, NASA has had its moments. It did start all this stuff out. It sent the first person to the moon. But, I mean, other than stuff that they've done on the International Space Station, what have they really done?
Yeah, other than having a bunch of things happen, and sometimes their technology didn't work out so great.
Yeah.
After all, you did have that one rocket rocket crash and burn and killing those teachers.
Yeah.
Unfortunately, rest in peace to them.
Yeah.
And you've had other things. I don't know, was it NASA or was it like a different country that got the hello or the wow signal?
I think it was NASA.
That's the only thing that they've been able to achieve, is getting a signal from God knows where.
But, I mean, recently, what NASA's done, they sent a satellite to collect data on solar flare, solar wind, everything like that. But they sent it they used that as the propaganda. Oh, look at this, we're going to do this. They were the first people to do that, to get as close to the sun as they did. And they had all the scientists who worked on it, names engraved into a plaque on the satellite. And it essentially got sent out, and it got burned up by the sun to become space dust. They sent it out with the sole purpose of being the first people to do that, because SpaceX was the first company to do so many things since the early 2000s, and they're still being the company to do the first of things.
Hey, we're NASA. We were the first people to burn up and waste money.
Yeah, they essentially wasted all that money and all that time just to get a little bit of data before the satellite burned to dust. I mean, there's no ingenuity in that. What are you supposed to do with that? SpaceX always tries to strive to be better. Like I said earlier, they actually have they actually plan on creating a mission to Mars in 2020. What's our government doing for NASA? Nothing. It's doing nothing. It comes over the plans, but this is also the same government that wants NASA's trying to use warp drive, which I've already talked about, is unpractical. It's not. You can't do it. But they still say that they're gonna do it for some God knows reason.
Oh yeah.
So think about that.
Yeah. What is your opinion, and you're probably going to go off about this, what is your opinion about the flat earthers versus normal earthers, and all these, and that one dude who tried to send a rocket into space just to see what it was like?
There's no room on this planet for flat earthers. That is my opinion. I don't care. Fight me. Flat earthers refuse any evidence and any creative thinking just because they want to be different.
Yeah.
They have
Good
no
job,
actual
little snowflakes.
They have no actual evidence. They have no actual proof of anything. No mathematics. No science. And they essentially just believe it because they want to believe it.
I blame the first flat earther recorded being the person who sent Christopher Columbus on his way, thinking the world was flat and he could go straight, and that there was an end of the world or edge of the world.
Well, see, that was the
Columbus
belief.
Proved them wrong.
That was the belief for so many years.
Yeah. But then again, they didn't have as much scientific data and scientists and all that. So, of course, they had to believe it's something.
Yeah. But the reason we developed science was so that way we can get away from it.
Yeah.
And we did. Until flat earthers decided to make a comeback for somehow.
Yeah.
Because they think all of this stupid stuff, it's ridiculous. They're just biased. You can't tell them anything. You can't show them any evidence because you can't even trust them either, because whatever evidence they do try to come up with, it's faulty math.
Yes.
They didn't plan it right. They didn't calculate it right. They didn't do anything right. And they just believe it because they want to believe it.
Yeah. It's just crazy. Well, are there any other areas to cover or last minute comments that you would like to make?
No, I think that's it.
Well then, I guess that's all we have for you guys. Thank you, Havoc, today. I enjoyed having you here.
I enjoyed being here. Thank you for having me.
No problem at all. I hope all of you enjoyed today's podcast and gameplay video, even though I just created a new wizard, went around and stuff. And if you did, please like the video. If you want more videos from me, please subscribe and watch them. Click the little bell icon next to the subscribe button to be notified of when I upload next. If you'd like specifics on what we've covered today, if you want to go more in depth or have questions about certain things, please do ask them in the comment section below, and I will get them to my friend here, and we will try to answer you as best as possible. don't be afraid. He loves this type of stuff, so he would not mind any questions you have.
Yeah, I'm very open-minded, so any challenge is good for me. I love it.
Yeah. Guess that's all we have. Thanks for joining, and I'll see you all next time.